Hello everyone, welcome to another episode of our design pattern series here at Code to Commerce. I am Mayank Pratap Singh and today we will be delving into the adapter design pattern. So what exactly is the adapter design pattern? Imagine you have visited Japan but you do not know Japanese. Now, within the translator app, you would add a sentence in English and it would convert the same to Japanese for easy communication. Here, you needed an adapter, which is the translator app, to bridge the gap for communication. Similarly, in software development, the adapter pattern allows incompatible interfaces to work together. But why do we need this pattern? Think of a scenario where you have an existing code that expects one interface, but you want to use a class that implements a different interface. Instead of modifying the existing code or the class, you can use the adapter pattern to make them work together seamlessly. Let's consider a problem statement. Suppose you have a duck interface with methods quack and fly. However, you also have a turkey class with methods gobble and fly. How do you make the turkey class work with the duck interface without modifying either of them? The solution lies in the adapter design pattern. We will create a turkey adapter class that implements the duck interface and uses a turkey object to perform the required operations. Tough, right? Let's do some coding to understand more using the same example. We have two main entities, ducks and turkeys. Duck interface. It is an interface that defines behaviors common to all ducks. In our case, ducks can quack and fly. Mallard duck class. It is a specific type of duck, namely a mallard duck, which can quack and fly normally. Turkey interface. It is an interface that defines behaviors common to all turkeys. In our case, turkeys can gobble and fly. Wild turkey class. It is a special type of a turkey, namely a wild turkey, which can gobble instead of quacking, and they fly, but only for short distances. Turkey adapter class. This is where the adapter pattern comes into play. The turkey adapter class implements the duck interface, which means it can be treated like any other duck. Inside the turkey adapter, it holds a reference to a turkey object. When a method like quack is called on the turkey adapter, it internally delegates the call to the gobble method of the turkey object it holds. Similarly, when fly is called, it delegates to the fly method of the turkey object. This way, a turkey object is made to behave like a duck object, even though they have different interfaces. Pretty tough, right? Let's dive more into the explanation part of the turkey adapter behavior. In the turkey adapter behavior class, we are making turkey act like a duck. But here is the thing. Turkeys don't quack like ducks do. They make a sound called gobble. So when someone wants the turkey adapter to quack, it tells the turkey inside it to do its best duck impression by gobbling instead. It's like telling the turkey, for now pretend you are a duck and make a quack sound, even though you usually gobble. Now, ducks and turkeys fly differently. Ducks are fast and can fly far, while turkeys are slower and fly short distances. To make the turkey adapter's flying match that of a duck, we make the turkey fly not just once, but 10 times in a row. It's like saying to the turkey, hey, since you are slower in the air, let's make you fly more times so you can keep up with the ducks. By changing how the turkey flies and making it gobble when asked to quack, we have managed to make it act like a duck. It's about finding clever ways to make turkeys and ducks work together smoothly despite their differences. Now, let's talk about pros and cons of using adapter design pattern. Compatibility. The adapter pattern helps make incompatible interfaces work together smoothly. It's like having a translator that helps two people who speak different languages understand each other. Reuse of existing code. With the adapter pattern, we can use existing classes that have useful functionalities, even if they don't quite fit our current needs. Instead of rewriting everything from scratch, we adapt them to work in our system. Flexibility. This pattern allows us to add new functionalities to our system without making big changes to the existing code base. It's like adding new pieces to a puzzle without having to redo the entire picture. Cons. Complexity. Using adapters can add layers of complexity to our code. It's like adding extra steps in a recipe. Sometimes it's necessary, but it can make things more complicated. Potential for confusion. If not implemented carefully, adapters can be confusing to understand, especially for developers who are new to the codebase. It's like trying to follow directions in a foreign language. It can be tricky if you are not familiar with it. And there you have it. By using this pattern, we can integrate new functionality into existing code without modifying either side. It's like using an adapter to plug different devices into the same socket. Please subscribe, like, share and hit the bell icon to stay updated with the latest videos. See you in the next episode.